two set of test scores have the same mean with different standard deviations, where the standard deviation for set 2 is greater than the standard deviation for set 1, which statement best describes the variability of these test sets? So variability kind of just means like your range, kind of how spread out is your data set. So if you take a look at actually, let me just graph this out. So let's say this is your test score. So maybe I'll write test score on the x-axis. So I'm just creating a graphical representation of what's going on. So this is our test score from, let's say, 0 to 100%, right? And then on our y-axis, this is going to be the percent of students that have this amount of test score. Now, when this says that standard deviation number 2 is greater than standard deviation number 1, this is basically what it's saying. So let's say this is test, let's just say this is test number 1. So this is the test that has the lower standard deviation. Let's just say it has a mean of 50. Well, the graph might look something like this, where maybe a high percentage of students have gotten 50% on the test, and then maybe like it kind of curves around the 50% on the test. But for test 2, we know that the standard deviation for test number 2 is greater than the standard deviation for test number 1. So if I were to graph this out again, here's what it might look like. So 0 to 100, let's just say this is percent. So once again, keep in mind that both of these test scores have the same mean. So I'm just going to mark a 50 on here. But maybe for test 2, the graph looks something like this. But notice how, yes, the mean is still 50, but kind of there's actually more values that sort of curve or kind of go around this 50%. So there's actually more values that actually there's actually like a wider range of values right over here. And, more and more values you notice here kind of deviate from the mean. So it's kind of called standard deviation because, the bigger your standard deviation is, the more the values deviate from the mean. So basically, the test scores are going to have like a wider range, right? So yeah, the mean is still 50, but now less percent of students might get 50%. And, the data is just spread out over a bigger range compared to this data, which might be, more compact. So yeah, data set 2 has greater variability. It's basically what standard deviation is. It's a measure of how variable kind of your data set is. All right, next question. All right, log 3 of x, g of x is the image of f of x, 5 units to the left. Equation represents g of x. All right, well, what you have to know is, first of all, when you're taking the Algebra 2 Regents, you're given a graphing calculator. So you literally could just plug in all of these values and just look at your graphing calculator. But, here's how I like to think about this question. Let's say if we have the function y is equal to x squared, okay? Now, if I wanted to move this function 5 units, all right, in this case, 5 units to the left, my bad, drew an arrow to the right. But if we wanted to move this graph 5 units to the right, well, the way you would do this is you would write it as y is equal to x plus 5 to the second power, okay? So let's say if this function right over here is f of x, well, if I want to move that function 5 units to the right, well, all I would do is I would write it as f of x plus 5. All right. So I would write it as f of x plus 5, basically add on a 5 to the sort of inside of the function, and you would move it 5 units to the left. And here's just kind of a graphical representation of this, right? You have x squared, x plus 5 squared, you're moving it 5 units to the left. If it was x plus 6 squared, 6 units to the left, and so on. So using this logic, right, in this case, right over here, this is our f of x. And g of x is when you move f of x 5 units to the left. So that means that g of x has to be, our new function g of x has to be equal to f of x plus 5. Basically, you're moving it to the left by 5, right? F of x plus 5. So in this case, what I can do is, if I know f of x is log 3 of x, log base 3 of x, or f of x plus 5, everywhere we see an x, we replace it with x plus 5. So it's just going to be log base 3 of x plus 5. And there we go. So there we go. And you can try this with decimals as well. Let's say this is log base 3 of 5. Let me just log base 3 of, log base 3 of x. If we have, it's annoying to scroll to this, but log base 3 of x plus 5. Well, well, you just move it back by 5 units. So the main thing to note is that whenever you're doing transformations with logarithmic functions, it's going to be the same as when you're doing transformations of a quadratic equation like this in kind of vertex form. So yeah, that's something important to note. Let's say we have this one. So when factoring to review the roots, which equations can be used? How can I factor this? How can I factor this equation? Well, notice here how I have x to the third power and 2x to the second power. I have negative 9x and minus 18. There's a reason why they wrote it like this. It's because, well, one thing you can do is you can factor this. You can factor this by sort of grouping the terms. So right over here, x to the third power and 2x to the second power, they both share an x squared term. So you can factor out an x squared. So it's going to be x squared. If you take away x squared from x to the third, you're going to get x. If you take x squared away from 2x to the second power, you're just going to get 2. So you can factor it like this. And for the second part, this is going to be minus. All right, you can factor out a 9. So if you take negative 9, right, this represents negative 9. If you take negative 9 away from negative 9x, you're just going to be left with the x part. If you take negative 9, negative 18 divided by negative 9, you're going to get plus 2. All right. Notice how the terms inside of these parentheses are the same, meaning we can factor this by grouping the terms. So you're going to get x plus 2, and the terms on the outside are going to get grouped together. So what I'm doing here is the terms on the inside, imagine this merged into one part, and then the terms on the outside, they get merged into one part. So you're going to have x squared minus 9. And then don't forget to set this equal to 0 because at the end of the day, it's an equation. So it's going to be equal to something. And, well, there we go. I mean, there's how you fully factor it. So which equations can we use? Which equations can we use? Well, if I take a look at the third option, I have x minus 2 times x squared minus 9. However, we said how right over here we have x plus 2 times x squared minus 9. So notice how number 3 isn't the kind of correct factoring method, right? We did our factoring, we got kind of down to this conclusion, and now we're just checking the answer. And just like the minus sign doesn't match up with the plus sign that we got. So any answer choice that contains 3 is going to be wrong. So, I mean, I guess we're down to the only option, which is just 1 and 2. Right? 1 is correct. It literally matches up with what we have here. You might be wondering where we get 2 from. Where do we get 2 from? Well, imagine if I wrote this equation like this. Imagine if I wrote this equation like x to the third power minus 9x plus 2x squared minus 18 is equal to 0. So basically, I just swapped these two terms. I just swapped these two terms. Now I can actually factor this by grouping. Both of these terms right over here have a common factor of x. So I can factor that out. So I'm just going to get x times x to the second power minus 9. For this part, I can factor out a 2. So I'm going to get plus 2, right? Positive 2, right? And then x squared minus 9 equal to 0. So notice how even though we changed the order of the middle terms, we can actually still factor this by grouping. And notice how if we factor by grouping, right, the kind of terms that are not in the parentheses get put together. So we have x plus 2. And then remember the terms that are the same, they get kind of grouped into one thing, merged into one thing, equals to 0. Right? Notice how we get the same answer as before. So that's something important to notice, right? So when you swap the terms of these two things, well, you're still gonna end up with the same answer. Another way to do this, one way to do this is you just plug this equation into your graphing calculator, and you can plug all 3 of these equations into your graphing calculator and check, which one of these graphs actually match up with the graph of this one. You can actually, another way to do it is just do the distributive property, and then just find out, if it matches this equation. So whatever kind of method you like, it's all good. What is the solution set to the... All right, this isn't in order because importing to test the sketchpad is kind of weird, but all right. What is the solution set of the equation this? How would I do this? Well, the thing to know is that, first of all, I have an x in the denominator. So whenever you have a number divided by another number, the denominator can't be equal to 0. So in this case, I have a denominator here with x, which means that x cannot be equal to 0. I have a denominator here, 3x plus 1. This is our denominator, and we can't let this be equal to 0. So imagine if we're kind of trying to solve for x. All right, so imagine if we're trying to solve for x. So you have 3x equals -1, x is equal to -1/3, and x, in this case, x can't be equal to -1/3, okay? So basically, all we did here was we took our denominator, we're going to set it equal to 0, we're going to solve for x, and whatever value that we get, it can't be, you can't have this x value as your answer, right? Notice how if I plug in -1/3 here, -1/3 times 3 is going to be -1. -1 plus 1 is 0, so you're dividing by 0. So yeah, -1/3 can't be the denominator, and these denominators are the same, so this one also can't be -1/3. So immediately, I go to my answer choices, and notice how, wait, no, I thought this was -1/3, but okay. Immediately we see that 2 of the answer choices have -1/3. So, yeah. Now, a quick and easy way to do this. If you don't know the answer, if you really cannot, really do not know how to solve this, well, just plug in the answers. If you don't know how to do this problem, plug in the answers and see what you get. And then if the equations match up with one another, then, well, it's the correct answer. And you just check it for all of the solutions. Well, let's learn how to solve this algebraically. Because, if this was on your teacher's test or something, probably going to say solve this algebraically. So, oh, and another thing you can do is you can graph these two functions. I mean, you can graph actually. So, we can graph 2 divided by 3x plus 1. And then for our second part, we can graph 1 over x minus 6x. So we can graph 1 over x minus 6x divided by 3x plus 1. Pretty sure that, yeah. And they should have a couple of intersection points. They should have a couple of intersection points. So, there's an intersection point here. I don't know if those intersect, but we'll see. But right now, one of our answers is apparently x is equal to 0.5. Apparently, that's one of our answers. And, you see this answer here, right? X is 1/2. So we can immediately bubble in the answer, but let's try to solve it algebraically. So, yeah. I mean, the Algebra 2 Regents, the graphing calculator just kind of carries everything, even if you don't know concepts. Just graph it out. So number 15 is this. So what I'm going to do is, all right, I want to get rid of 3x plus 1. I want to get rid of this denominator. And I also want to get rid of the x in the denominator. So what I'm going to do is I'm going to multiply the whole equation by 3x plus 1. All right, and what this does, right, if I multiply the whole equation by 3x plus 1, it's gonna cancel out with these denominators. However, I still have an x left behind. So all I'm actually going to do is I'm going to multiply this whole equation by x and 3x plus 1. That way, we get rid of the 3x plus 1, and we get rid of the x in our denominator. So look. All right, first we have x times 3x plus 1 times our first term. The 3x plus 1s cancel out, and 2 times just the last term, 2 times x is just going to be 2x. All right. This x right over here cancels out with this x, right? If we do kind of the distributive property to everything, right? This x is going to cancel out with this x, so we just have 1 times 3x plus 1, which is just going to be 3x plus 1. Finally, this term, we distribute to our last term. This is going to be minus, and in parentheses, right? Because don't forget, this minus sign right over here, it's minus this whole entire thing. So make sure to put the minus sign kind of in the parentheses, right? Make sure to put the parentheses all over the whole thing with the minus sign. So 3x plus 1 cancels out with this, and x times 6x is going to be 6x squared. So we have the resulting equation, 2x equals 3x plus 1 minus 6x squared. Move the 2x to the other side, move the 2x to this side, so we get this. Negative 6x squared plus 1 plus x is equal to 0. We just write it like this, so it's in standard form. could use the quadratic equation to solve this, but we're just going to multiply everything by -1. So I'm going to get 6x squared minus x minus 1 is equal to 0, right? I multiply everything by -1. So that means that all the signs change from either positive to negative or negative to positive. And now I can actually factor this by grouping. So I'm going to multiply my leading coefficient. The leading coefficient represents, all right, so what the leading coefficient is, all right, you look at your highest term, right? Our highest kind of power is x squared. And so the leading coefficient will just be the coefficient of the highest power. All right, multiply leading coefficient by the constant term. Constant represents the term without an x. You get -6. What two numbers multiply out to be -6? What two numbers multiply out to be -6 and add up to be the middle term? In this case, the middle term is -1, right? You can think about this -x as -1x. So the two numbers have to add up to be the coefficient of the x term. So -1. Correct combination, you can try out a couple of values. Correct combination is -3 and 2, right? -3 times 2, -6. -3 plus 2, -1. So you can actually rewrite this equation as, so we have 0 is equal to 6x squared. So hold on. 0 is equal to 6x squared minus 3x plus 2x minus 1, right? All we did here was imagine if we took the middle term and we just broke it up into these two numbers that we just found. So we broke the middle term up into -3 and +2. Notice how if you add these two numbers up, you get back -1x. So everything remains equal in this equation. If I factor out a 3x from these two terms, and if I factor out a 1 from these two terms, I'm going to get, so if I factor out a 3x, I'm just going to be left with, if I take away 3x from 6x squared, I just get 2x. I get -1. If I factor out a 1 from this, I'm going to get 2x minus 1. Notice how these two terms are the same thing. So we do the same thing as we did before. They merge into one term. And then the non-parenthesis terms merge into one term. Non-things in parentheses. 3x plus 1. And this is equal to 0. Don't forget that. And so all we have to do now is just set these two equations equal to 0. So in order for this equation to remain true, either this part's equal to 0 or the other part's equal to 0. So either 3x plus 1 is equal to 0 or 2x minus 1 is equal to 0. So for this second equation, 2x, if I add 1 to both sides, I get that x is equal to 1/2. And for this one, if I subtract 1 from both sides and divide by 3, I get x is equal to -1/3. However, remember back in the beginning, we said how x cannot be equal to -1/3. So actually this solution right over here is what's known as an extraneous solution, meaning that it doesn't work. It's a fake solution. All right, because we said how if we plug in -1/3 into the denominator, we would get 0. So just cross that one out. So the only solution that remains valid is x is equal to 1/2. And guess what? When we graphed it out earlier, x is equal to 1/2. So, this just kind of shows you how like OP graphing calculators are. You didn't even need to do that much work. You could just graph it out and you would get the answer. So, it's kind of crazy. All right. Savannah just got her contact lenses. Her doctor said she can wear them 2 hours on the first day and increase the length of time on the nth day. Okay, so this right over here is sort of like, this right over here represents a sort of sequence, okay? So look, a sequence goes something like this. So we have 2 hours on the first day. Let's just say 2 hours on the first day, then 2 hours, 30 minutes on the second day. So 2.5 hours, then 3 hours, then 3.5 hours. And you see the pattern, right? It's a sequence of numbers. And in this case, it has something known as a common difference. So in this case, every day, you're increasing the amount by half an hour, right? Half an hour. So you notice a sort of pattern, right? It's a sequence of numbers where there's sort of a pattern. In this case, the pattern is that you're adding 30 minutes each day. So that's going to be your common difference. Okay. Now, so on the first day, we said how 2 hours, right? So to represent this, we have to use this kind of script. So a sub 1, this is how you kind of write it, right? Your first term is 2, your second term, a sub 2, that's 2.5 hours, and so on. All right. Okay. Now, let me see. Let's check answer choice number 1. Let's see if this is the correct answer. So it says a sub 1 is equal to 120. Now, the question, don't forget that it says, which formula would not be appropriate to determine the length of time in either minutes or hours? So these formulas right over here can be in minutes or hours. In this case, since for answer choice number 1, it says our first term is 120. 2 hours is the same thing as 120 minutes. So that means that our units are in minutes. So 120 minutes. Let me just write that down. And it says a sub n is equal to a sub n minus 1 plus 30. So what this means is, for example, let's say if we wanted to find out the second term. N is equal to 2, which means we're trying to find the second term. So we're going to get a sub 2 is equal to a sub n minus 1. So that means a sub 2 minus 1, right? So everywhere we see n, we just replace it with a 2. So a sub 2 minus 1. 2 minus 1 is just 1. A sub 2 minus 1 plus 30. And if you plug in a sub 1, which we said was 120, we'd get a sub 2 is equal to 150 minutes, which is 2.5 hours. So, everything matches up for the first equation. And we want to find out the formula that would not be appropriate. So this can't be our answer. What this formula is basically saying is, okay, if we want to find out the amount of hours the glasses can be worn for a certain day, well, you just take the number of hours in the previous day and just add on 30, right? And that's literally what the problem says. It says, if we want to find out the hours you can wear in a certain amount of day, just take the previous hour and add up 30, because 30 increases by 30 each day. So, yeah. Number 3, it's literally the same thing, except it's in the units of hours. This represents 2 hours, right? And this one is saying, okay, so if we want to find out the amount of hours you can wear in a certain amount of day, we'll just take the previous day, which is n minus 1, right? If you're on the second day, then the previous day before that is just going to be 2 minus 1, right? Or the first day, right? And so you just take the amount of hours from the previous day and add up and add on half an hour, or 0.5, right? Let's look at number this one. So let's actually, if you don't know how to do these problems, what you can do is you can plug in values. So we know that in the first day, she wears it for 120 minutes. And right over here, right, the units here are in minutes. Right? Because if you're starting off with 90, then it's probably in minutes, because a sub 1 is going to be equal to 90 plus 30 times 1, which is 120 minutes. So, that makes sense, right? So number 2 actually looks like, it does actually work, because, if you plug in 1 for n, you get 90 plus 30, which is 120 minutes. And then every day after that, it just increases by 30, hence why there's like an n at the end. What you got to realize is that kind of the first 2 equations are a recursive series. A recursive sequence. Recursive sequence. Meaning that the way you find out, let's say, if you wanted to find out the amount of hours she can wear on the 4th day, you need to know the amount of hours she wore on the day before, plus 30. All right. So without information from the last day, you actually can't find out the value of a sub 4, right? You have to do it kind of manually, step by step out. Kind of, if you were given, let's say, the value of a sub 1, then you would have to find out the value of a sub 2, then a sub 3, and then after that you would finally be able to find out the value of a sub 4. But for our 2 equations down here, they're written in the form of a sub n is equal to the first term plus the common difference. So the first term plus the common difference, which is represented by d times n minus 1. So, with this formula, let's say if we wanted to find out, let's say the 4th day, right, the amount of hours you can wear on the 4th day, well, it turns out that you actually, it actually doesn't well, you can actually just plug into the formula, and then everything works out nicely. I'm gonna do like a video on that to kind of show y'all. I don't want to get like too much in detail because I already spent hella long on this problem. But basically 3 answer choices eliminated. Number 4 has to be our answer. Notice how if we plug in 1 for n, we get a sub 1, right? If we want to find out the amount of hours on the first day, it's going to be equal to 2.5 plus 0.5, which is 3 hours on the first day. And we said how she works 2 hours on the first day, so that doesn't match up. A of x is the inverse of a function is what? Oh, to find out the inverse of a function, I'm going to rewrite this as y is equal to a to the x. Now, when you're solving for an inverse of a function, like, let's just say if we have a graph where, let's say, when x is 1, y is 1, when x is 2, y is 2. This is a horrible example. When x is 1, y is 2, when x is 2, y is 3, when x is 3, y is 4, and so on. Now, the inverse of the function would look something like this. So when x is 2, y is 1. When x is 3, y is 2. When x is 4, y is 3. So it's literally the exact same thing except you flip the x and y values. So if we have, let's say, the graph of y is equal to 2x plus 1, well, if I told you that the inverse of this function is going to be x minus 1 divided by 2, all right, so look, let's say if we have the graph of y is equal to 2x plus 1. Now, the inverse of the function is going to be equal to, y is equal to, or I should say f of x is equal to x minus 1 divided by 2. I'll show y'all how to get the inverse of a function. I actually have a video on that, but I'll show you how to get the inverse of a function later. So this is the inverse of the graph y is equal to 2x plus 1. Notice how when x is 0, y is 1. Well, look right over here. Sorry. All right, look. When x is 0, y is 1. For the other graph, when x is 1, y is 0. Notice right over here. When x is 0, the y value is negative 1/2. Well, negative 1/2, 0, right? So the values are just swapped. And actually, graphically, what we can realize is that the green graph right over here, the original function, imagine if we flipped it around this line. So imagine if we reflected it across this line, then we would get the purple graph or inverse. So if a function is an inverse of another function, it's going to be that function reflected across the graph of y is equal to x. All right, so that's like a graphical kind of relationship you got to know. So in this case, to solve this equation, what we have to do is we have to swap these two values. So we get x is equal to a to the y power. Now what I'm going to do is I'm going to solve for y. So in order to solve for y, I have to take log base a on both sides. So the a's cancel out, and I get log base a of x is equal to y. In case y'all don't know what logarithms are, once again, I'm pretty sure, like 100% sure, I have a video on that. Feel free to check that out. All right. Cosine function. What is the values of a, b, and c? A right over here represents something known as the amplitude. B represents something known as the period, and C represents something known as the midline. Let's start off with C first. The midline is literally just the... All right, so you look at your graph, right? Notice how for a cosine graph, it's like a wave. So there's going to be a high point and there's going to be a low point. In this case, our high point is 5, low point is at y is equal to 1. Now, this C right over here just represents the line that's in the middle of these two values. So what's in between 5 and 1? That's going to be 3, right? So C has to be equal to 3. And immediately, C is equal to 5, C is equal to 1. Cancel. All right. Let's take a look at A. What do you think A represents? A represents something known as the amplitude. And it's literally just the distance from the middle to the top point. So this distance right over here is just 2. Yep. So A has to be equal to 2. So immediately, we kind of just get the value. But, immediately we kind of just get the answer. But let's just find out what B is. B, it represents the period, okay? So it represents kind of a point where this graph completes one cycle. So B just represents kind of when this graph right over here completes one cycle. So right over here, notice how the graph completes one cycle in a span of from pi over 2 and to pi over 6. So the difference between those values, is just going to be pi over 3. All right, so that's how long it takes for this graph to complete one cycle. All right, that's how long it takes the graph to complete one cycle. Now, to find the period of the graph, which is represented by the letter B, what you do is you take 2 pi and you divide it by this value you got. So pi over 3. So 2 pi divided by pi over 3. Keep, change, flip. You already know the deal. Pi's cancel. You get 6. Boom. There we go. All right. Which equation directly represents the parabola focus and directrix y is equal to 7? So, what you gotta know is the equation for a parabola. So the equation for the parabola is going to be 1 over 4p times x minus h to the second power plus k. All right, where p is the distance from the vertex to the focus of the parabola. So look, imagine if we have a parabola. All right, it says we'll focus at -3, 3. So -3, 3 is somewhere over here, and directrix as y is equal to 7. So that line's right over here. Now, a parabola is defined as the set of all points. So imagine if we have a parabola. It's defined as the set of all points that are equally distant from a point and a line. So if I take this value right over here, notice how it's the same distance from the line and this point, right? If I take, let's say, this value right over here, notice how it's the same distance from the line to the point. So now, look, so whenever you have like a point, right, you have this point, which is something known as the focus, and then you have the line known as the directrix. Now, the parabola is always going to be, or you can think about the directrix as sort of being like a barrier. So this represents like a barrier. And the focus is always inside the parabola. So the parabola is going to get sort of blocked by the barrier. So then it's going to go down and it's going to sort of kind of swallow the focus, right? The focus is going to be inside this parabola. If I have a parabola where the focus is, let's say, somewhere over here, and then let's say the directrix is down here, well, you can think about the directrix as a barrier. So the parabola is going to look something like this, where the directrix kind of blocks it from going any further, and it's going to swallow up the focus. You can also have sideways parabolas, which use a different equation. A sideways parabola is x is equal to 1 over 4p times y minus k squared plus h. And don't forget that h comma k represents the vertex of our parabola. It represents the vertex of our parabola. So for us, you can have a sideways parabola as well. So that means that the directrix would be here, sort of blocking the parabola. Focus would be inside the parabola, and so on. All right. Now, which equation represents the focus? All right. So we kind of establish how our parabola will look like, right? Our focus is at -3, 3, and our barrier or directrix is sort of at y is equal to 7. So we know the parabola is going to look something like this. Now we know that the graph of y is equal to x squared looks something like this, right? And the graph of y is equal to -x squared, it's literally just going to be that function, but flipped around. So that means that these two graphs right over here, they have a negative sign in the front. All right, when a parabola is facing downwards like this, it has a negative sign in the front. So that means that immediately we can eliminate answer choice 1 and 2 because they do not have a negative sign in the front. Notice answer choice 3 and 4 have a negative sign in the front. So we're keeping those answers. Now, how do we find the distance from the focus to the vertex? How do we actually find out the vertex of our parabola? Well, it turns out that the focus of our parabola is actually just directly underneath our parabola's vertex. Sorry, our focus is directly underneath our parabola's vertex. So this point, the point of our vertex for our parabola, is actually at the point -3, 5. The reason for this is because, look, we know that the vertex is directly, we know that the focus is directly below the vertex. The vertex is directly above. We know that the vertex is directly above our focus. So it's going to have the same x value as our focus, right? We also know that the vertex, right? Remember, the parabola is a set of all points where the distance from this line right over here, this vertex, this line is the same as this vertex to our focus. All right. So in this case, right over here, our y value would have to be equal to 5. Because think about it, right? The distance from y is equal to 5 to y is equal to 7 is 2. And the distance from y is equal to 5 to our y value of 3 is also 2, right? So notice how the distance is the same. So if you want to get the y value for your parabola's vertex, what you do is you take the average between these two y values, and that's going to give you the value in the middle, which represents the vertex, which is equidistant from the focus and the directrix. All right, now that we have the focus, now that we have our distance from our parabola to our focus, we have the vertex itself, we can just plug it into our formula. So it's going to be y is equal to 1/4 times p. P represents this 2, right? It's this distance from this parabola to this directrix. From this vertex to the directrix. So it's going to be 4 times 2, which is equal to 8. And don't forget, remember, our parabola is facing downwards, so in the front, it's going to have a negative sign. So it's going to be x minus h squared, so x minus -3 squared. Right? Because remember, the vertex of our parabola is h comma k. So x minus h squared is just going to be x minus, in this case, our h value is -3. So h minus -3 squared plus 5, or plus k, right? X, this negative cancels out with the other negative, so you get x plus 3. And, well, there we go.